Okay, now we're back with the cotangent parent graph, and cotangent is the reciprocal of tangent. So in our last video, we found these ordered pairs using the unit circle for the tangent function at x values in increments of pi over 4, 1 revolution around the circle. Since cotangent is the reciprocal of tangent, we can go ahead and take find the reciprocal of each of these to find this corresponding points for cotangent. So reciprocal of 1 means the cotangent of pi over 4 is 1, because the reciprocal of 1 is 1. Then at pi over 2, the function for tangent is undefined, which makes the reciprocal, since 1 over 0 flips over to become 0 over 1, that reciprocal of undefined is 0. Okay, then 3 pi over 4, the reciprocal of -1 is -1. At pi, the reciprocal of 0, 0 over 1 is 1 divided by 0, which is undefined. So we're going to have a vertical asymptote on our cotangent parent graph at 0. Okay, then at 5 pi over 4, reciprocal of 1 is 1. At 3 pi over 2, the reciprocal of undefined, right, 0 divided by 1 is 0. Then 7 pi over 4, the reciprocal of -1 is still -1. And at 2 pi, the reciprocal of 0 is undefined. So we'll have another vertical asymptote then at 2 pi, which means our vertical asymptotes are going to be, there'll be one at the origin and then plus or minus k times pi because they're pi units apart. So let's go ahead and start by putting those asymptotes on the graph. We'll have an asymptote here along the y-axis, then at pi, and at 2 pi. Since they're pi units apart, we'll be back at -pi and at -2 pi. So the asymptotes are x equals plus or minus k times pi, where k is an element of the integers. Okay, then at pi over 4, we have a point at 1. At pi over 2, we have a point at 0. Then at 3 pi over 4, we're down here at -1. And so we can see that this curve comes wiggling through those guide points and along those asymptotes. So as we repeat this pattern between the other pairs of asymptotes, then we can get a picture here of 4 cycles of the cotangent parent graph. So coming along those asymptotes, bending through those anchor points, and that'll be our parent graph of cotangent. So the cotangent function is decreasing instead of increasing like tangent was, and our asymptotes have shifted. They're starting at 0 instead of at pi over 2. There's no y-intercept since we've got an asymptote along the y-axis. There are zeros. Our first non-negative 0 is at pi over 2, and then the zeros are all pi units apart. So zeros are located at x equals pi over 2 plus or minus k pi, where k is an element of the integers. Okay, then that makes our extrema next, and there are no absolute or relative extrema, so that's a none. Okay, next if we look at the domain, domain is all real numbers except these undefined values for x. So all real numbers except x cannot equal plus or minus k times pi because they're asymptotes there, and our k must be an element of the integers. The range, just like the tangent function, was or is all real numbers, and the period, just like the tangent function, is pi units. Description of the shape, this is just like the tangent, a vertical wiggle between the asymptotes, but the vertical wiggle in cotangent is a decreasing function, where in tangent it was an increasing function. So looking at a demonstration of the cotangent graph from our Geogebra applets that we've been looking at. Right, here's quadrant 1. I'm having a hard time getting that to connect, but as we go through quadrant 1, then we hit this 0 here at 90 degrees, and then in quadrant 2 we get the bottom half of that wiggle. Remember, tangent is positive in quadrant 1, so we're above the x-axis. Cotangent and tangent are negative in quadrant 2, so now we're below the x-axis for the negative section. Then at 180 degrees or pi radians, that's a vertical asymptote. Then we head into quadrant 3 where tangent and cotangent are positive. So now we're up above the x-axis again in quadrant 3, and quadrant 4 is negative for tangent and cotangent, and so we're down below the axis, the x-axis in quadrant 4. Then back to 0, 360 or 0, 2 pi for another vertical asymptote. And that would be one revolution of the circle, which produces 2 iterations of our cotangent parent graph.